Hi everyone. I actually conned Lindsay into helping me out on this today. It was more a matter of I've put you in to do it, so and he has already done a lecture on the WIA AGM and also at Gibbs Tech, so it will be an interesting one from Lindsay. I will, at the end of it, I'll go through the DAPnet or POCSAG digital system. On the screen at the moment, you'll see a dashboard that is my repeater at home, or one of my repeaters at home. I run PyStar on my system to run my repeaters, and you will see the operation of what's actually live. I'll just try and bring it up a bit bigger there, might make it a little bit better for you. And in this, just quickly goes through this, there is a configuration area that allows you to set up your repeater, your hotspot or whatever, the way you want it. And this is set up, as you can see, as a duplex repeater. At the moment I'm running DMR, a D-Star, NXDN, and I've got POCSAG also turned on. Now this repeater is actually running on 439.875, and it seems to work quite well for coverage for me anyway. Unfortunately it doesn't quite cover up to here where we are, but you can set it up. As you can see, I can turn YSF on, I can turn P25 on. I can also run YSF to DMR, YSF to NXDN, YSF to P25, and DMR to YSF, as well as DMR to NXDN. So it depends on how you want to set up your repeater or hotspot. Remember, this can be run on a hotspot as well. It's up to you how you want to run it, what you want to run. You might only have a YSF radio, like a Fusion, Yaesu Fusion radio. Therefore, that might be what you want to do. So you'll pick the YSF side of it, and you might want to go YSF to whatever. And that's up to you as to the setting that up and operating it. As a repeater, I'm trying to I run through repeaters at home, so I'm trying to spread these digital modes across the three repeaters, including my VHF, which is also analog. So it'll also come in as an analog as well as digital. So I run that separately. Still run PyStar, still runs the same system, and this is all running on the MMD Vm network, which Lindsay will discuss with you, which was written by and maintained by Jonathan Naylor, G4KLX, and he still is very much involved in it, although he's trying to pull back a lot lately. And he's got a lot of other people helping as well. And of course, all this is all downloadable from GitHub, and you can get it all from there. PyStar will come from the PyStar UK network, and Andrew MW0, basically MWO MW0 is his call sign. So that's it's one of those ones that's hard to say when you're talking to him on the radio. But Andy looks after that PyStar, and he's very much into the whole amateur side as well. So he likes what he's done, and he works with Jonathan, and they both in the UK, so they do keep in contact quite regularly. All right, well look, I will pass it over to Lindsay now to go through with what he needs to. We'll just need to swap our computers here, and Lindsay can come up with his PowerPoint presentation, and then I'll come back with the DAPnet after that.
Come on.
It's just finding it, Lindsay.
It's just blowing through at the moment.
There we go. Right. Basically my history of this, I got involved close to 2 years ago now. Started off Dave, VK2JDS, brought a DV Mega into one of our meetings and said, check this out. And actually did a contact as a demonstration contact with Matt, VK2DAG, by the Mmd repeater. Basically I got hooked ever since. What I plan to cover is a bit of the history of MMDVM, how Jonathan got started with it, a little bit of the technical side, a little bit of where we're at with some of the new technologies coming out, and yeah, bit of an overview. So these are some of the people we have responsible for it. A lot of very, very intelligent. There's too many names to list, but these are some of the main ones. Anyway, so basic history. Back in 2009, Jonathan wrote the D-Star repeater project. And that was one of the first open source D-Star repeaters that are available. In 2010, he wrote the IRC DDB gateway for D-Star, which then allowed the repeaters to link to each other instead of having to use the G2 network after the open source repeaters were kicked off the G2 network. Then come to 2014, a few people said to him, oh, you should build do a DMR repeater. And at the time, Jonathan looked at it and decided it was too difficult, but he kept it in the back of his mind. Then basically in 2015, he went to Dayton. He was invited to Dayton with the Northwest Digital Radio guys. And while he was there, he went and spoke to the DMR Mark guys and said, hey, I'm Jonathan, I'd like to looking at building an open source DMR repeater. And they said, oh, no, you can't do that. If you've got to have a DMR repeater, you've got to be Motorola gear only. Can't have open source DMR repeaters. We'll take your D-Star software though, thanks. And yeah, that was a challenge to Jonathan, and basically challenge was accepted. So the MMDVM itself, there's a couple of parts of it. You've got the hardware interface itself, which connects to the actual radio, and that does the analog to digital and digital analog conversion. You've got the MMDVM host software, which that'll run on a Raspberry Pi computer, whatever. That basically is the intelligence of the repeater and does the control and repeater linking. And then there's the MMDVM firmware, which that runs back on the hardware interface, which I'll cover a little bit more further down the line. Good way of reusing underutilized repeaters. And for Amateur Radio Central West Group in Orange, it was a way of getting a digital repeater on the air for a price that we could afford. We could never afford a commercial brand repeater. Whereas with the MMDVM, we got a digital repeater on the air for less than $500 running multi-mode. So in the early stages, the main issues Jonathan had was choosing suitable hardware. He went through a few different ideas. He didn't want to use sound card interfaces because they're difficult to interface, lots of headaches. You can have everything from simple DC bias issues through to low quality from the different sound chips. There's no consistency there. He needed a good analog to digital converter and digital analog converter. And he didn't mind having the hardware separate from the modem. He didn't mind that, and his experience had showed him that you could do whatever you want in software. If you can dream it, you can do it in software pretty much. So it meant he didn't need to use dedicated vocoder ICs or specific application-specific ICs. So the end result, we got the MMDVM host software and firmware, which then runs on the MMDVM hardware. In the end, how he decided on the first MMDVM was an article Barry Chambers used an Arduino Duo to sample an SDR and display the spectrum graph. And Jonathan figured that could work for DMR sampling, and so we started experimenting with that. And it worked. The other question comes up, why DMR? And it was an interesting technical challenge. No one had done it, and something that looked interesting. Tdma was new, and as noted there, it's the same technology used in GSM and Tetra. With DMR, you've got 2 time slots. GSM, you've got 4 time slots, and I believe it's the same for Tetra. So what is Tdma? Basically, of course, one repeater, multiple time slots, multiple QSOs. So you can have one QSO going on time slot 1, another one going on time slot 2, completely unaware of each other. The repeater itself transmits continuously and listens on one frequency. The users transmit on one frequency, but in short bursts. So you have user 1 on time slot 1 will transmit for, I think from memory it's 28.5 milliseconds. And then they will actually then go stop transmitting, and then user 2 will then take the frequency and they'll transmit for 28.5 milliseconds. You have guard times in between, and that's how it works. The thing with it is the only reason this project got off the ground is because the repeater itself transmits continuously. If we had the repeater doing switching like the end users, this never would have got off the ground, because amateur equipment cannot, they just don't have the rise time required. It's sub-millisecond rise time is required for the end users. But because the repeater is just continuously transmitting, not a problem. So that's a bit of an idea of what's going on. So you can see there the 2 time slots up the top. The base station is transmitting continuously. You can see there swapping from time slot 1 to time slot 2 and back. You got the cache in between, and that's basically just your guard time between the 2 time slots. And your signalling is actually in the middle of an active frame. So it's not at the end where you might assume. It's actually the signalling and synchronization is in the middle of a frame. And you can see on the mobile station at the bottom your two bursts of data. You got your 30-second for a single time slot to 60 for 2, and then your guard time in between. Of course, with this system, the timing needs to be very accurate. The base station is what provides the timing for the QSO, and the mobile station, they take their timing back from the repeater. But that does have to remain very accurate, because you have that time. The timing information is not there all the time, and I'll get further into DMR frame further down. The downside of this is that you are distance limited. You have about specifications say 150 kilometres. In reality, you get a little bit more than that, but 150 k's is pretty much the limit for a duplex DMR transmission. Simplex or DMO mode is a different matter, because you don't have the 2 time slots. You only have 1 time slot repeated. But yeah, in duplex mode, because you've got to have that time between the users, yeah, it is a very, very serious issue. The DMR specifications themselves are well written, very, very long. It's about 4 chapters. Each chapter is about 200 pages. Very well defined, very, very well defined. Doesn't tell you how to do something. It'll tell you this is what your transmission should look like. Go and do it. It doesn't say this is how you can do it. So that's what Jonathan had to figure out. He knew what he had to create, but he had to figure out how to create it. He did learn that generating the base station signals is fairly straightforward, because it's just generating packets, and the layout of the packets is specified in the specifications. Just got to calculate a few different kinds of checksums and forward error correction. So while it's simple, a fair bit still had to be written before the first basic transmissions could be created. There were 2 main areas that he spent a lot of sleepless nights working on. The first one is, how do you detect a transmission of 27.5 milliseconds out of nowhere? Because the repeater, the repeater's just listening all the time. It's just listening to background noise all the time when it's inactive. And all you get when you key up a DMA radio, it's just a 27.5 frame of data, and that's the wake-up frame. And so, and with no timing information, just out of nowhere, he had to figure out how to detect that 27.5 milliseconds of data, decode it, realise it's a, hey, wake up, and then fire up the repeater. So that was one of the first things he had troubles with. And the second one is how to maintain lock when there's no synchronisation information available. Now, I'll expand on that one further, but you don't have synchronisation information inside every DMR frame. You have half a dozen frames or so where there's where it's just free running. So you have to maintain lock to your transmission without that information. So that was the second one that he had troubles with. So this is a single frame. This is 27 or 30 milliseconds. The frame is 27.5 milliseconds. You have payload, which is voice data. Then, as I said before, you have the synchronisation and embedded signalling halfway through. So that'll be anything from ID numbers to, as I said, the synchronisation information. Any extra messages that might be sent along with the frame, whatever. And then you have another lot of payload there. And so that's a single time slot, single frame of DMR data. So this is your typical voice transmission. So that might, an example there, the first two frames will be the wake up frames. Tell the repeater to wake up and start transmitting. And then you'll have a voice frame. And then you notice there we've got 5 voice frames with no synchronisation data. And then at the end we've got another frame with synchronisation data. And that's why maintaining timing was so difficult, because you got the first 3 frames, you got the data there, but then you got 5 frames of just free running. So keeping the timing in that better part of 300 milliseconds there was very difficult, and he did spend a lot of time working out how to do that. As I said, finding frames with synchronisation is fairly simple, but of course it only occurs every 6 frames. So the obvious answer was, and what they started in the first place, was using the oscillator on the Arduino Duo. And it is rubbish. It's something only like 15 ppm, 15-20 ppm oscillator on the Arduino Duo, and it was no good at all. The DMR specifications are down to something like 1 ppm is what you've got to have. For timing, he actually uses samples internally for timing. So one sample, 1 millisecond is 24 samples, just on the side there. But the solution to timing was he started using an external TCXO on the Arduino Duo. And the hard part with that was getting the Arduino to accept the external timing input. But once he got that figured out, then it significantly improved transmissions, and they started having reliable results. Okay, so the mobile station is locked to the information transmitted from the base station. So the base station is providing the timing, and the mobile station has got to maintain its timing from what's coming from the base station. The catch there, which was in the earlier slide there, is basically the signalling telling one mobile station, okay, stop transmitting, the next one can transmit. And that's how you have the changeover between the 2 time slots. I don't think there's anything more on this slide. So this is basically how Jonathan worked out all his timing solutions, synchronisation, whole lot. This is a block diagram of what's going on inside the MMD Vm. So on the far right, that's just pure serial data. That's the connection between the MMD Vm modem and the MMD Vm host running on the computer. You have the DMR transmitter, DMR receiver. That's the 2 separate programs that are running inside the Arduino Duo. Now they run independent of each other, and they take the serial data and convert it into voltage levels to go out to the digital to analog converter, and vice versa, an analog to digital converter, and convert it into serial data to go back to the modem. The MMDVM modem itself, it doesn't know what that serial data is. It doesn't care. It just sends the serial data to the host, and the host works out, is this a valid transmission? Do we want to do something to this? Do we want to ignore this? All that sort of stuff. The host is what does the intelligence part. The modem does, all it does is take the RF interface and convert it to serial data. So to keep the two programs in the Arduino Duo synchronized, the transmitter and receiver, this is how he did it. Is he sends the audio data straight out, but he also has control data looping back in there into the receiver there, and that's how he keeps the two separate programs in the Arduino synchronized, so that the receiver knows what the transmitter is doing. Of course, it works well. This was actually taken back in May, this screenshot. It's expanded some more, but where was it? Last week when we were looking there, Brad, I think it's something like just under 3,000 repeaters were online on the Brandmeister network, and 7,500 hotspots. So the network is still growing. Now, keep in mind, this is only the Brandmeister network. So these figures here are only talking about MMDVMs that are connected to Brandmeister. It's not talking about MMDVMs that are locked to D-Star, or MMDVMs that are sitting on the VK DMR network, which there's a hell of a lot of those. I have 5 hotspots running at home, only one of them sitting on Brandmeister. So yeah, these numbers are very, very encouraging, and gives you a good idea of what's going on, and how well MMDVM has been working. And yeah, it's really exciting stuff. Once Jonathan got DMR working, D-Star was simple to add. He'd done it with the sound card repeater project. He was able to simplify it with, based on previous experience of that, he simplified it and put it into the MMDVM firmware. Still works via Ddb gateway as before, no change there. Why reinvent the wheel, as he said. Fusion was the next one he added. There's a old wives' tale out there that Fusion is the same as P25, just with 1 bit changed. That's not true. But you could say that Fusion's a distant cousin of P25. Reasonably well implemented protocol. Documentation is reasonably good, except WiresX. He had to backwards engineer WiresX and create a custom reflector system for it. But once he got that figured out, it works and works well. P25 was the next one, and my personal favourite. I think it was you that sent him a P25 radio, was it?
Yep, I sent him the P25 radio so he could experiment with. Shipped it here from Australia over to the UK.
Yeah, that P25 radio came from America to here, and then here to the UK.
The UK, so yes, it was.
That information on the bottom there is out of date now.
Yes, won't happen with
that. I wrote this back in May, so that ignore that last paragraph there. But other than that, yep, P25 works well. My favourite mode. Yeah.
Do you mind if I just quickly interject to say now the Quantar, the actual Quantar, can connect directly to the MMDVM network now, and via a Cisco router, which is something else that has been sorted out and works well, as we have up at Summersby. So our Quantar up there is on the MMDVM network.
So, as I basically said,
439, is it?
439 950. Sorry.
Yep, all good. So as I said before, basically you got the you got the modem hardware, the modem firmware, and then the MMD Vm host, which runs on the computer. And so that's basically how it all fits together. The modem itself, the modem firmware / hardware, to say the modem from now on, listens to all enabled modes at once on the MMD Vm modem. If you have a hotspot, because the hotspot use a so like this, a hotspot, we're actually abusing a ADS7021 data IC, which I think I've got a bit more details further down here, but it's actually an ADS7021 data IC which we're abusing to do something it wasn't designed to do, and that's but they can decode and encode GMSK and 4 FSK, I think it is. So Andy CA6JAU figured out that we could use them to generate the hotspots. But the downside is with the hotspots, they'll only do one mode at once. So if you have multiple modes enabled on your hotspot, it's got to switch through them one at a time. So if you have DMR, D-Star and P25 enabled, it'll listen for a little while on DMR. Then it'll change to D-Star and listen for a little while. Then it'll change to P25 and listen for a while. Then it'll go back to DMR. The downside of that is while it's listening on P25, it can't hear anything on D-Star. So you have a delay time on key up. For the end user, it's generally not a problem, but it means that you've got to wait for it to scan around for the different modes, whereas the modem is able to listen to all, because they work a different way, able to listen to all the modes at once, because it's just the modem is connected into the FM discriminator on your repeater, and it's just straight analog to digital conversion, and it's just listening for whatever. The filters are able to be shared between some of the modes, so for example Fusion DMR, so that means the modem is able to reduce CPU load, although we're now using modems that have a lot more CPU horsepower than in our original Arduino Gateway. We've basically moved on from those, now using the STM32s, which fair bit of CPU horsepower in a little device for an embedded device.
Is that one that you're talking about, the STM32? Is that the hat I got?
Okay, so technically yes, this is an STM32, but a different model STM32.
Yeah, that's right. Same thing.
Yeah.
Okay.
It's different model. This particular one here has similar horsepower to the original Arduino Duo, but the ones that we're using for the modems is the STM32 Nucleos, which they're like 180 megahertz ARM cores they are. And as I said before, the modem does the minimum amount of work before it sends it off to the host software, which is running on a computer, Raspberry Pi, whatever. And the host does all the intelligent part. The host software will look at the data, work out what it is. Is it a fusion transmission? Is it a DMR? Is it whatever? It'll decide whether the call is valid or not. Decide, do we send this? Do we keep this local? Do we send it out to the network? All those sort of decisions are done at the host level. The modem does none of that. None of those decisions. The host also controls the displays, whether they're using a Nextion or a I2C display or a generic LCD display. That's actually one of the first MMD VMs built. This is the first one Jonathan built. This is actually a Zumboard version 1, and you can tell that because, as I mentioned earlier about the TCXO problem, the timing problem, so that's the modem there. And that second little board up there is holding the TCXO after they realised and figured out you need the TCXO to make things reliable. That's using a couple of SC301 data radios, and what have we got? The power supply board up there, but yeah, that's basically it. And a next-gen display. So that one at the top left is one of these. It's a design by Blass EA7 GIB, and that's about the cheapest way to get a MMD Vm hotspot, because you can buy all these modules individually. You can, and nice and simple. The only modification you got to do is change the TCXO on the radio board. Other than that, plug it in, put the firmware in, off you go. So from top left going around, up top left you got a DC to DC noise generator. Then you got the STM32F103, which holds the MMDVM firmware. Bottom right you got the actual ADF7025 RF module. And bottom left, that's just an Orange Pi Zero. This one in the top middle, anyone wants to have a look at that, it's in the ute. This is the former VK2 RDP repeater out at Parks. And that's actually the first one I built. That's about 2 years ago when I first got into MMDVM. I bought a DV Mega, and then a month later I'd built a repeater. So I really hopped in a big way. Top right, a couple more boards there. This one's a different design by Blass. That one is designed to sit on top of a Raspberry Pi, but otherwise does the same thing as this. That's a SP8 NTH modem board sitting on top of an Arduino Duo. That's in the middle bottom there is a hotspot designed by Alex S56AL, and he designed that one, well, it's the same as the one on the bottom left there. The one on the bottom left is the MMDVM HS board, designed by oh, that's appalling. I know. DF2ET and DB9, Mathis DB9 MAT and Flow DF2ET. They designed the MMDVM HS board, and that's what that one is on the bottom left. And the Chinese fakes and all that sort of stuff you see coming in, most of them are rip-offs of their board.
Chinese ones.
Yeah, I've got one there too. Yeah. But that board is 0402 size componentry, and that is, you sit there, pick and place tweezers. Takes me about an hour to pick and place components on that particular one I built. Took me about an hour to pick and place components, and then you put it in a reflow oven and cook it. And surprisingly enough, I've done half a dozen of those, and every single one of them worked first time, which was rather incredible. The one by Alex S56AL, he's designed that using 0805 components, and he designed that specifically for anyone who did not have reflow equipment to be able to build their own. And Dave VK2 JDS, I gave him the microcontroller chip, the radio chip, and a blank PCB, and I gave him a challenge, and he came back, done it, and he just put the board together from components he had scrounged out of old radios, things like that, and yeah, it's rather relatively, compared to the one on the left, relatively easy to build your own hotspot board. Of course, if you want to build your own one, the easiest way, you just get a blank PCB and put one of these together. Or buy one of the Chinese ones. Not that I'm recommending that. The next major development that came along was Mt Gateway. The problem with the original MMDVM host software is it was limited to one server. If you wanted to change servers, you had to shut the software down, change the settings, and start it back up. And Jonathan didn't like that, he liked choice. So he invented Mt Gateway. That came out, touch over 12 months ago now. And that allowed more than one server to be connected, or more than one network to be connected to the repeater or hotspot at the same time. It works by doing talk group rewriting. It does. So if you go in on, for example, how I had RDP set up, if you go in on talk group 2, time slot 2, talk group 6, you'd come out on the XLX network, whatever XLX reflect was connected. If I went on the time slot 1 and put in any talk group I wanted on time slot 1, it'll go out just on the Brandmeister network unchanged. Or go to time slot 2, talk group 8, then I'd go out on the DMR Plus network. So that's how it takes the talk group, rewrites it, then sends it out to the network. There's there's an example there. Yeah, there you go. So that's how I had RDP set up, and it gave the option. You could go just by selecting the talk group. You could go out on the network you wanted, and that's a bit of how it's controlled. I don't like reflectors, but that's how a lot of it. Jonathan likes reflectors. I don't like reflectors. To each their own. But that's how you could control reflectors and do switching and all that sort of stuff. Now this is again out of date, but this is back in May. NXDM was brand new when I wrote this talk. NXDM is pretty mature now in MMD Vm. We've got all the cross modes which can be done at the hotspot level. Fusion to DMR, DMR to Fusion, DMR to NXDN. I don't have an NXDN radio, but I've worked NXDN a fair bit. Going on a DMR radio, and the hotspot just what it does is it strips because the audio codec is the same between them. The compression codec is no difference. It just strips the DMR signaling, injects some NXDN signaling, sends me out on the NXDN network. And vice versa, when a transmission comes back, it strips the NXDN signaling, adds DMR signaling, and sends it back to me. And so we've got, and particularly with the XLX reflector system, we've got full cross mode compatibility. Doesn't matter what mode you're using. You can talk to someone else using a different mode: P25 to DMR, DMR to Fusion, Fusion to D star, and so on. Well, that pretty much covers it. Yeah, so in 2015, Jonathan set out to write DMR repeater modem. It has grown a hell of a lot from where he started. It's gone from strength to strength. We got it on multiple hardware types. It's a good way of reusing underutilized or repeater equipment that's just sitting there unused. We've got the hotspots now, which provide a cheap and very accessible way for people to join us on the networks and provide so many different things to experiment with. And yeah, it's cross-platform too. Linux, Windows, whatever. It's all good fun. And that's it.
All right. Well, thanks very much, Lindsay. That's really good. Good to be able to see that. I have actually seen it on the on the original presentation you sent me, but good to see it actually up there. All right, one other thing that's been added since then, of course, we have... I think this was going to work anyway. Give me a second. I can get this to... Okay, right. One of the other things that has been added since then is the DAPnet POXAG network, which is the paging network. And once again, as you'll see when I go through, this has been running for a while, but the expansion was due again to Jonathan, G4KLX. It just grew once he got involved. And so what you have here is your POXAG, DAPnet, CAPnet, VK-AppNet. They're pretty well, the standard. The POXAG is the original commercial network and still runs today. DAPnet is a European amateur network. CapNet's a Canadian, of course, VK-AppNet, which is not actually up and running yet, but that's going to be the Australian amateur network. So it'll... Okay, POCSAG. Pretty simple. Acronym. As you can see there, Post Office Code Standardisation Advisory Group, which is a British thing. So that's where the POCSAG name came from. Now, as I said earlier to a couple of people, for people that don't know what paging is something that was used. That was the way that you got information passed to a person on the road, sending originally a numeric code to a person, which could just been a code that was used internally. They knew what it meant. It could have been a phone number. And you were driving along, and if it was a phone number, and which I remember doing, and pulling over to a phone box, which there used to also be, and making a phone call, calling the number that was sent to you. And that's what happened. And of course, as I put down there actually was a time before mobile phones. So that's the way it is. And that's how it was sent. That's how people got in touch. Now, the next thing they did, of course, was they went into alphanumeric. So it was a little easier. So a system could be sent, or a message could be sent, which was only 80 characters, by the way, which still is the same, could be sent to you. So you could get one message, or you might have got 3 or 4 messages, one after the other, which was information that you required. And I often got that as well. And it was, again, prior to mobile phones. And that was the way you, again, got the information sent over to everybody. Frequencies used here in Australia. Around the world, of course, frequencies are different depending upon the country. We're still using 148 meg and 450 meg range in the commercial area. DAPnet, okay. What it stands for is Decentralised Amateur Paging Network. That's what they call it in Europe. It's been operational in Europe for a few years now, from what I understand. So they've actually had it running over there, and they've been using 439.9875. But this year, we're talking June, Jonathan was actually requested to come over to the Friedrichshafen, I think that's, I can't remember. Friedrichshafen, a ham radio event. And when he got over there, he was asked to actually look at expanding it and seeing if he could put it into his MMD Vm network. So he left there, and actually within about a week, he had the first write for them to check and test and see if it was going to work. Now, this is something Jonathan does. He's a contractor, and he lives out of London somewhere, and at the moment I think he's contracting in London. So he leaves home of a Monday, goes to work, staying in London somewhere. When he's staying in the hotel or where a bed and breakfast or whatever, he sits down and writes code. And then that's what he does for the amateur community. That's basically what he's been doing. Anyway, he got the system up and running. It's now incorporated into his MMD Vm network, and I will try and send a test later. And I think someone here has actually got a hotspot that might be working and operating, and if it's running on 439.125 and it's got POCSAG turned on, and it has, okay, because I can't get mine to work, unfortunately, it's not set up on the right network. I'd be able to do a test, but I can show you another way as well. Okay, so with the expansion of the network has been adapted, so it's revitalised the paging system as far as in the amateur community. Obviously not much here in Australia, but it is used throughout Europe quite a bit, and they use it for their emergency services, and I believe it's being used in the USA now as well, since this, again, emergency services, similar to our WISN, and they're getting messages sent out for people that are on the go, and of course, you're talking about, instead of carrying a radio or a mobile phone where they may not be able to, you can carry around a small device, which is, you know, not very big. Put it in your pocket, vibrates, or you leave it, have it on vibrate or or noise, whatever you want, and you'll get the message come through and see what it's all about. So that is still being used, and it is what it is. It is just strictly an alphanumeric paging system. So that's the basis of it. The DAPnet network coverage. Okay, transmitters. They are classed in wide area or low power local devices. So your wide area is your repeater style, up to 25 watts is the recommendation. And of course your low coverage are your little hotspots that we're talking about. So that'll work within your home area, mobile in your car, whatever you want to run, the same as you do with your MMD Vm network. So you can have that running at the same time. So if you want to be running POC-SAG as well as YSF, you can do that. And how, of course, it'll work is the POC-SAG or the DAPnet message will not be transmitted until such time as there is any free time on your hotspot. As soon as there is a break in anything, it'll immediately, because the message is so small, the data just goes out really quick. It's just gone, you know, millisecond, and you've got your data transmitted. So in between breaks, it'll actually send that information. Again, the way it's been written into the gateway that Jonathan has produced for this. Okay, to become a user, you must have a user account on the DAPnet network, which is the German network. So if you go out onto the, which I'll put some links up in a minute, and they'll also be on the information, you can go out and you can set yourself up as a user. Now what a user will allow you to do is to be able to send to a subscriber. As a user, you're not automatically a subscriber. That's separate again. There are three areas within the DAPnet network. That's a user, a subscriber, and a transmitter. So that's what you have. They also have things like nodes as well, but I'll come into that in a minute. So if you want to send a message out, you can just become a user. You don't have to be a subscriber. So if you know that you have maybe it might be a group, might be a club. So you might just have a club account which is just send messages out to their subscribers. So you can just be registered as a club. It has to have a call sign. You must have a amateur call sign to be able to do it. And the same thing as a subscriber. Going into it here, the subscribers. Now, you're locked into a RIC number, which is your radio identity code. So every subscriber has to have a RIC. So you might log in, like I have, as VK2HK, and then I requested, because my DMR ID, which is something that you have to have for your DMR, my DMR ID is 5052110. So what I did was I shortened it down to 52110, the same as I did for NXDN. And that is my RIC code that that's registered on the system. And this is what they're suggesting that you do, is bring it back down to the last 5 digits. The sixth first digit is used internally by them, so you can only have 5 as far as the RIC number is concerned. So they're suggesting just use your last 5 numbers of your DMR ID, and providing there is no others, and yes, there will be the possibility that there might be something from another country that tends to be the same as your last 5 digits, then you'll get it, or they'll maybe give you a suggestion of something else. So that's what I've done. I've just done that with mine. And okay, the nodes. There are nodes at the moment. There's a few nodes out there. We don't have one here in Australia because the core is being rewritten. The current version 1 is being rewritten into a version 2, and they don't want to release any more nodes anywhere until the version 2 has been released. When that happens, we will actually get a node here in Australia as well, and that will be run by the VK AppNet group. So they will organise all that, and that is a group of a few people that's there. I'm not part of the group. I am on the Facebook group. They have been in contact with me because I have a registered transmitter, and so we are looking at all that. Now, okay, VK-AppNet. There you go. It's easy to understand. It's VK Amateur Paging Network. That's why they picked it, and they're waiting for the waiting for the version 2 software. The frequency. Right, as I said, the rest of the world is using 439.9875. So the Europe, UK, I believe, as well as USA, going to adapt that frequency. The reason they wanted to do that was so that anybody, any amateur, could carry their little pager anywhere in the world and still be able to receive messages. The problem is in Australia, because of our band plan, we already have repeaters on that frequency, and it's going to be a bit of a problem. So it was going to be hard to obviously have those repeaters set up as. And you must remember here, we are only talking about transmitters, no receiving required. So you only have a transmitter out there, so the license is only for a transmitter. And it's it. It just transmits the data, just does bursts of data and sends it out. The same as the current paging system we have now. So they've looked at and they've requested 439.125, which if you look into our band plan, it's earmarked as an internet gateway with 439.150. And hence why some people are suggesting putting your hotspots on 439.125 or 439.150. Now, from what I understand, the discussions with the WIA are looking promising for that being allocated out as the POCSAG frequency, or for the amateur, I should say the VK-AppNet frequency. There's only one licensed repeater here in Australia on that frequency, and he is now part of, the owner of that is now part of the VK-AppNet group, and he's happy to actually be able to utilise that as a transmitter. So that's what we already have at the moment. Okay, amateur paging, good, bad, who cares? Really, it's that simple. You know, you can use it or not. It's up to you. You either want to use it, you want to play with it, you may want to utilise it within a club, within a group, within WISN. There may be reasons for it. It can also be used for sending telemetry. So if you want to, you can have it hooked up via software, so it'll automatically send you page out if something goes wrong with your transmitter, or if something overheats, or whatever. You can actually have that page go out and continue to send X amount of times. Now, paging can be specified. We actually have groups. So there is an all group, which means that's worldwide. Everything goes out to every transmitter that's out there. In Australia, we only have one group, and it is VK-all, which means that every transmitter in Australia would be able to receive a VK-all. Now, other countries like Europe have broken it down to subgroups. So they may have a German all group, but then they may have other subgroups depending upon the area within Germany or anywhere within Europe. And we can do the same. We could break it down to New South Wales, or we could break it down to a Central Coast, or we could, it is only a request to DAPNet to be able to do that if we want to go ahead. And that would be dependent upon how many people we're talking about. So they would look at the subscriber and see where that subscriber is and how many subscribers we have and the reason why we want to do it. And then be able to allocate that out. So that's just something else. It's not on there. It's something I've just found out recently. So, so again, it can be used. It may not be able to. It's up to you, up to the club, up to the groups, as to what they want to do. Again, what can they be used by? Just which I've already gone over there. Emergency monitoring. Again, it's up to you. Okay, sending a message. Yes, as I said, you've got to be a registered user. And if I was to send a message out, I actually have I have an app here on my Android. Now, unfortunately, if I can get my Android to fire up on me, here we go. Unfortunately, I can't show you this, but I can, if anyone wants to have a look. But that's the app just showing up. At the moment, I've just got it showing up some groups of, I'll just try and bring this around a bit more. These are areas there. Some of the blue areas there, it's very hard to see. You'll see some of the areas have got 61 people, 19 people, 294 in one area. So we're talking about transmitters here, and they would be hotspots, so they'd be just personal as well as wide area. Now, the problem, as you can understand, is if you're transmitting, and we all should realise this, if you're transmitting on the same frequency all at the same time, what's going to happen? You're going to get garbled information sent, because this receiver is going to pick up information saying, what am I receiving? And they're going to be out of phase. So you're going to have a phasing issue, as you do with the commercial system. So you've got 16 different time slots that you select. And it will be up to you as the person, as the owner of that. Hang on, sorry about that. It will be up to the person to go and find out who else is in the area, if they've got a large transmitter, or if it's just a personal hotspot that may be causing some interference. And you can go onto the map, the DAPnet map, and it will show you every transmitter in your area, and it will show you the time slot that they're actually transmitting on, so that you can then go in and say, oh, okay, I won't pick that, I'll pick this and this and this, because you could have overlaps in your coverage area, as you do with the current commercial system. You have an overlap area, they will always overlap, and they're always transmitting on the same frequency. So again, they have the same thing. They run different time slots in the different areas, and the data will go out on that particular time slot, and that's how it will work. And once your pager has received it, it won't receive a second one. It'll only receive the first one. So it'll pick up the first one it gets, and that's what it will get. So if it gets another one that's coming straight out of phase, it'll actually garble. But if it's on a different time slot, it'll only pick up that time slot. That's it. So it'll pick up that first time slot, receive it, and that's it. That's how it works. Now, as I said, there is only one app at the moment that allows you to be able to go and send a message. You can log in to the DAPnet system, and you can send a message from there once you're a user. You can log in under your Android phone, but there's nothing for iPhone, which was quite annoying to me. And so about 2 weeks ago, I sat down and started to write an iPhone app, which is just about finished. And depending upon how well it goes, because Apple unfortunately are so picky in regards to allowing apps out there, unlike the Google stuff. Google sort of will allow virtually anything without checking it. Apple won't. I may actually have an Apple version of it coming out. So it's on my big iMac at home, and I've been doing some testing on it. So I'm hoping it'll be as simplified. It won't be like the Android one. The Android one will allow you to log into their website and do all that sort of thing. Mine is just strictly going to allow you to pick the login, the person that you're going to log in as in the user that will send it. It's only sending REST API, so it's just sending a REST API out. So it's just sending a post to their website, and that's what will happen. So all I'm really sending is my username, my password, the person I want to send it to, the rest of the basic information, the text message, and the group that it's going out to. And that's it. That's all it is. So the app's pretty simple, but again, it's still got to be approved by Apple. And that's will be at least something that might be, and if that all works out, then I'll just put that out there free for anyone to be able to download.
Better idea, just buy a decent phone instead of an Apple.
Hey, I run Mac, thanks.
Excuse me. You got to understand these techie types. If it doesn't run on bloody that weird bloody Linux stuff.
Oh no, I don't have a problem with Linux, mate. That's why I use a Mac and not a Windows machine. What do you think a Mac is?
He's giving you a hard time, but he's running a Windows machine.
I know that. Yeah.
That's funny.
So that's really about it as far as the messaging system. There is some reference information which I will also be passing out, where you can get hold of these Chinese pages, which work. I think they're at the moment at $58 US plus a bit of shipping if anyone's interested. The DAPnet. You go to the DAPnet site. There is obviously it's German, but there is an English version. You can download it. There's a wiki, so you can go to the DAPnet wiki and give you all the documentation on the core and how the system operates. So that's all out there. But I think that's going to be. I think this will probably end up in the next smoke signals anyway, won't it? These links.
Whatever you want.
Yep, that's all right. Well, I can put the links in. That's easy. So.
You provide, I'll put.
No problem. Okay, yeah, as I said, conclusion, yeah, all right, well, I'd just like to thank everybody for being here and thank Lindsay for jumping in, even though I did con him into doing it. Well, I just told him he needed to do it. So
I got the email that said, yeah, I
Actually, it was my fault because I mentioned you, I popped you down in the...
He did too, actually, yes, yeah. There was one thing that I thought Lindsay picked up on before, just quickly before I conclude. You were talking about the DMR hang times and keeping your... Hadn't come up. Oh, what happened? Okay.
Wouldn't have this problem with a Windows machine.
Didn't like going away from the
Windows machine
PowerPoint.
would have already failed.
Yeah, I know what.
Restart.
No, I think I know what it was. It's just, there we go. I forgot to close down the PowerPoint. That was my problem. Okay, one of the things in here, as far as keeping modes operational, open, you'll notice in the configuration of this Pi-Star dashboard, we've got such things as RF hang time and net hang time. Now, the reason for that is that it doesn't matter whether it's DMR, D-Star, YSF or whatever. If you've got your hotspot or your repeater and you've got multiple modes running on it and you don't want to suddenly lose a mode, you might be in a QSO, it's up to you to set up how you want to run that, because what will happen is if it goes into DMR mode, you'll see I'm running 20 and 5. The reason for that is that if I am running a QSO, it means that I'm allowing 20 seconds before it drops off that mode and goes looking elsewhere. That's on RF. So at the repeater level, I am listening for 20 seconds for someone that's transmitting a signal directly into my repeater. Now, on the net side, I'm only looking for 5 seconds. So if there's someone coming in, it'll only hold that for 5 seconds before it goes off and looks for another mode. Now, it's up to you as to how you set these up. It's your system. And originally, and I'm actually quite proud of this one, originally that didn't exist on Jonathan's system. And I was continually seeing problems. This is going back to DMR and P25, those sorts of things, because I was involved with the P25 testing, as we mentioned. And I said to Jonathan, as a repeater owner, I could see problems here, and can't we break this up and have a hang time for RF and a hang time for net. And he said, that's a great idea. Didn't think of it, and that's what it did. So we put that in. So it allowed you then to adjust that. So as a repeater or hotspot owner, you can then go in and adjust that information to suit. And it's up to you, as I said, as to how you set them up to hold that. Any other thoughts on that?
Yeah, no, I did actually miss that. Yeah, so
Yeah.
good catching up on that.
No, that's all right.
But obviously, it means if you have your hotspot connected to two separate reflectors, if they're both quiet, then it's not a problem because you're not going to have interference. But yeah, no, if you're talking on DMR to someone, and as Ian said, someone fires up on say P25 without that hang time, if they're talking when you unkey, then immediately the repeater will then change over to P25 mode, and you won't know what's happened. So yeah, so that's what the hang time's for. Is so you don't, if you're using it, you don't suddenly get it hijacked by another conversation on a different mode you might have the repeater connected to.
Yeah, and I know some people will run 20 and 20, so they'll run 20 on RF and 20 on net. And that's, again, that's up to you. And experimentation really is the best way for yourself to work those things out as to what suits you. All right, well, I'm pretty well done.